These are the second set of notes that we're going to take on circles in geometry. Circles are a really big deal in geometry. They're a lot of the basis. If you think about our constructions, they're based on circles, so they're a big deal. In this section, we're going to talk about area of sector and arc length. Now, first of all, let's make some definitions. A sector, had a little issue with the iPad there. A sector is a region bound by two radii of the circle, so that would be AC and BC in the problem below. Make sure you're following along and not just writing stuff in so you'll understand it. It's bounded by two radii of the circle and the intercepted arc. The arc would be arc AB. So that little piece, it's like a piece of the pie if you want to look at it that way. And if we want to know what the area of that piece of the pie is, it's part of the whole area, isn't it? So if we want to know what part of the whole area of the circle, all we have to do is tell what fractional part of 360 degrees this M is here, M degrees. For instance, if it, we'll do some problems in a minute, but the fractional part of the circle, if you look at, here's the pi r squared, that's the area of the circle. This is telling me what part of the area of the circle I have. So if I want to find, for instance, let's look at number 1. That'll give us a good hands-on example here. Find the area of each sector. Give answers in terms of pi and round to the nearest hundredth. Okay. Those are kind of contradictory instructions there. So you're going to give two answers is basically what's happening. When you give an answer in terms of pi, you're giving an exact answer. When we round, we're giving an approximate answer. So we're going to give two answers. One of them is going to be the exact answer and one's going to be a rounded answer. Okay. So if you think about it, the area of this circle would be pi r squared, right? You can reason this out. Well, my radius here is 12, so that would be pi times 12 squared. That would be 144 pi, but I don't have all 145 pi shaded, do I? I only have part of it. I have 131 degrees out of 360 degrees. That's the part that I have. So I'm going to multiply the area of the circle by 131 out of 60 degrees. That's the part out of the whole. Come on. Part out of whole. Remember, the whole circle is 360 degrees, and the part is however many degrees that central arc, that central angle makes to cut off that arc for that sector. So here it was 131. Okay, so 131 over 360. You know, if you've got, you need to reduce those fractions. So it looks like 144 and 360 can be reduced. Let's see, if I divide 144 by 4, I get 36. So this is going to be, I'm going to come down here, 131 over times 36. And if I divide 360 by 4, I get 90. Oh, I can still keep going because 90 is divisible by 4. So I didn't know it's not. It's divisible by 2. So 2 goes in here 18, 2 goes in here 45 times. Now, this is when a graphing calculator is pretty handy, because if we want to know have we reduced it all the way, I'm getting 2, 3, I need to put pi up here. I forgot to include my pi when I wrote this down here, so I'm going to write it in now. I get 2358 pi over 45. So I'm going to see if that reduces any further. 2358 pi, which you can't read hardly on the app, divided by 45. And I get 52.4. Let's see. I'm going to do math, enter. So this reduces to 262 over 5. So both of those numbers were divisible by 9. Okay, that would be the exact answer. If I were to want to know the approximate answer, that's the answer in terms of pi. Now, if I want to know the approximate answer, I'm going to take that 262 divided by 5, and I'm going to multiply it by pi, and I get the approximate answer, I'm going to write it over here just because, I've only got so much room to work here. So if I round to the nearest hundredths, that means 2 decimal places. So on my calculator, I'm seeing 164.619455. So I'm going to go out 2 decimal places. I have 0.619. The 9 rounds the 1 up to 2. Let me write that here because some of you have had some rounding problems, especially in the 9th grade. Y'all have been a little confused about that. So the 9 rounds that up to a 2. So this is my approximate answer, and the answer with pi in it would be my exact answer. Okay, here's another example. We want to know the area of the sector ABC. So we know it's part of the whole area. So let's see, what part of the whole area do I have here? Okay, so it's part of the whole times the area. I have 25 degrees out of the 360 degrees, don't I? That's what this arc is right here, so that tells me how much I have. And the area is pi r squared, but here my r is 5, my radius is 5. So let's see, 25 and 360. 5 should go into both of those. Let's see, let me just multiply all this out. 25 times 25 over 360 times pi would be, I'm working on my exact answer right now. I'm just going ahead and squaring that 5 squared. Now let's see, 360 is divisible by 5. Now let's see, so 5 will go into 25, 5 times 5 will go into here 72 times. Let's see, the factors of 72 are like 9 and 8. So 2, can I get any 2s or 3s out of the 5s and 25s on top? No. So the exact answer is going to be 125 pi on top and on the bottom 72. So my sector ABC is, this is my exact answer. Now let's get the approximate answer. Approximate's when I turn it into a decimal. And remember, I have to divide 125 by 72 and multiply it by pi, or I could punch it in the calculator as 125 times pi and then divide by 72. You can do it either way. My approximate answer is the area of that sector is about 5.454153. It keeps going, but I wanted to work on the rounding with you guys just in case you're struggling. If we go out to 2 decimal places, we're going to round to, you would think it would be 0.45. We look at the digit after. 4 does not round the 5 in front of it up, so I'm just going to write it's about 5.45. And this is, since it's area, it's going to be square or feet, so I'm going to put feet squared on it. I forgot to do the units on the previous problem, but you can go back and do that. Okay, on this last problem on the first page, if we look and we want to know the area of that sector, what is the part to whole of the area of that circle? We just have part of the area, right? So the part to whole, in this case, it's 90 degrees out of 360 times pi r squared. Well, the radius here is 1. So this one actually is going to reduce really nicely for us, unlike the other ones. 90 goes into 91 times, 90 goes into 364 times. 1 squared is just 1 pi. 1 times 1 pi on top would give me pi on top, and on the bottom it would give me 4. So I'd have pi divided by 4, and that would be my exact answer. That's my exact area, and it's meters squared. Pi divided by 4 meters squared is the exact answer. The meter squared's on top. It just looks like it's on bottom because I was trying to cram it in. My approximate answer, if I wanted to turn this into a decimal, I could just punch in the calculator pi and divide by 4. And if I look at my decimal answer, 7853981, blah, 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 but they want it to the nearest hundredths, so I'm going to say that's about. So hundredths, remember, tenths is the first place, hundredths is the second, except that this 5 is going to round that 8 up to a 9. This would be rounding to the nearest hundredths. I don't have a whole number part out in front just because in this problem we didn't have one. You always write, when you round it to the nearest hundredths, you always write the whole number part out front, and then they're just telling you how exact they want their decimal rounding to be, okay? So this would be meters squared. That's the approximate answer. If you were a scientist, you would probably take the exact answer, because if you're going to do something with this and it involves precision, you want the exact answer. If it was you and me at home measuring for a flower bed, we could just go, you know what, I'm just going to go, that's about 0.79 meters squared, or about 0.8 meters, and we could round it, and it wouldn't affect anything. So what we do with our answer depends upon what we need to do with it once we get it. So we're going to practice doing both ways, because you never know what you might do with something. You never know what career path you might take, or if you just maybe eventually might want to use this at home someday.